aspirants, this question is from GATE 2019 Mechanical Engineering paper set 2, question number 8. Endurance limit of a beam subjected to pure bending decreases with option A, decrease in the surface roughness and decrease in the size of the beam. Option B, increase in the surface roughness and decrease in the size of the beam. Option C, increase in the surface roughness and increase in the size of the beam. Or option D, decrease in the surface roughness and increase in the size of the beam. So we have to say how endurance limit of a beam changes, whether it decreases with surface roughness and size or whether it increases or vice versa. We will start by understanding fatigue failure. Any material can fail by multiple ways, multiple reasons. One of those reasons can be fatigue. Fatigue failure happens due to a certain number of cycles of time varying stresses. So the loads that are applied on a material are time varying and is cyclic or reversal in nature. That can cause fatigue failure. In this context, we have the term called endurance limit or endurance strength or fatigue strength. These are the three different terms used to denote the same term, endurance limit. So endurance limit indicates that value of stress below which if a material is stressed, it will never fail by fatigue, even for infinite number of cycles. So as long as fatigue failure is considered, if you have a certain value of stress, a particular load that is causing the material to stress under endurance limit with the reversal nature, it will never fail. But if there is a stress above endurance limit in a certain number of cycles, the material may fail due to fatigue. There are chances of fatigue failure if the stress is above endurance limit and it is cyclic in nature, of course. But if it is below endurance limit, there are no chances of fatigue failure, even for infinite number of cycles or millions of cycles with reversed cycles of stresses. So this endurance strength is generally determined by experiments. And let's say we have got the endurance strength from experiments as sigma E dash. So this is endurance strength obtained from experiments. Now, in order to correct this endurance strength, because experiments are performed under specific conditions for specific material of specific size of specimen. So in order to account the effects from practical conditions, we will have to apply some factors to this endurance strength that is obtained from the experiments. Also, endurance strength is evidently a property of the material, but there are also other factors which affects this endurance strength, and those factors namely are, it can be size of the object or body that is made up of a material with a particular endurance strength, surface roughness of it, applied load, and temperature in which that object or the body is kept. To account the effect of all these, we have certain factors, that is C size factor, C surface that accounts for surface roughness factor, C load that will account for the type of applied load, whether it is bending or axial load, and C temp or C temperature that will account for the ambient temperature of the material. So finally, the modified endurance strength, let that be sigma E, can be written as sigma E is equal to product of all these factors into sigma E dash. So the corrected or modified endurance strength can be given by this formula. Value of all of these factors will never exceed 1. That means if these factors are perfect enough as per the experiments, the value will be 1. There will be no decrease in endurance limit or endurance strength. If there is any deviation from the experimental condition, that is obviously possible, it is practical enough, the value will be less than 1. So maximum value that these can take is equal to 1. Hence C size, C surface, C load and C temperature should be always less than or equal to 1. In no case will the endurance strength be increased from the endurance strength that is obtained from experiments. It will only be reduced or it will be taken equal to this value sigma E dash. That is why we can say that always whenever the surface roughness will increase, this endurance strength will decrease, or the size will increase, the endurance strength will decrease. We will also see this how practically size and surface roughness are affecting the endurance strength, or they are decreasing the endurance strength. So first one, that is size factor. Now there is a clear relation between the number of flaws and the size. If the size is small, the probability of flaws being present will be lesser, but when the size increases, this probability of presence of flaws will also increase. So we can say as size increases, probability of presence of flaws, defects and voids will increase, and that is why as the presence of flaws is increasing, presence of voids is increasing, strength of that material is going to reduce. Let's look at the another factor, that is surface roughness. We have the surface of two objects made up with the same material. The condition is both of these objects are made up of the same material. One is having a very smooth surface, polished surface, but one is having a rough or unpolished surface with many hollows and highs on the surface. So we can clearly say when the surface of this object is stressed, the stress is distributed uniformly on the surface. While in the second case, we can see that there are many highs and hollows, and there are points where the stress might concentrate. There might be a higher value of stress at certain points compared to the other points. Stress concentration is the primary reason why surface roughness is going to increase the chances of failure, and hence there will be a decrease of endurance strength that we are going to modify. So the answer for this particular question is endurance limit of beam subjected to pure bending decreases with increase in surface roughness as well as increase in the size of the beam. So it is option C. To study more about fatigue failure theories, you can refer to the video lecture 25, fatigue failure theories, fatigue strength correction factors, from the course Basics of Material Engineering by Professor Ratnakumar Annapattulla, Department of Mechanical Engineering, IIT Madras. I hope you understood this explanation. Thank you.